Alright, it's day 347 off the grid, and guess what? It's Postbag. Yes, I thought I'd have a bit of a Postbag because I've had a couple of packages come in the last couple of days that I haven't got around to opening yet because I've been so busy with Radio Foxton and whatnot and the stupid car, you know. Yeah. So, let's slice these open and see what we've got inside. Oh, and this is probably the first time I've used this Gorilla Grip, which Owen gave me ages ago to help improve my videos. Well, I just figured that I'm not too concerned about the quality of my videos, but I thought that how am I going to open a package like this without something helping. So there we go. Slice her in. Oh, there's something inside. What have we got? What have we got? It's bubble wrap. There we go. No. Alright. Okay. Oh look, it's a solar charge controller. I got it cheap on Trade Me, so you know I just put one of those bids on for a laugh and I happened to win it. You know, can't have too many charge controllers. They're always good fun to play around with. And this is the first time I've got one of these kind of quite common ones. But if you've ever seen my video of the charge controller that makes the strange tones, I suspect that these are pretty much the same deal, because they've got exactly the same terminals, exactly the same indicators, and exactly the same sort of press through these different work modes, which are basically for controlling lighting, turning lights on and off, when they'll come on, and well, how long they'll stay on for once darkness falls and stuff. So yeah, 10 amp controller, auto selectable between 12 and 24 volts. But these, if this is the same as my other charge controllers, they don't really do true PWM. There's sort of a mixture of PWM and sort of on-offing going on there. So there it is. Feels pretty sturdy. But it's got the same nasty way of heat sinking with the inside there, which I won't show right now, but inside there the MOSFETs will just be pressing up against this back panel, I bet you. I bet you. So that's that, yeah. And of course, like all of these controllers, I bet we can guarantee, just grab this multimeter here. You can see that. Oh, cool. Positive earth. There's the positive of the load terminal. There's the positive of the solar terminal. There's the positive of the battery terminal. Yeah. Continuous connection there. That little analog meter makes a great continuity tester. Digital meters drive me nuts when I'm trying to test continuity. So, that's that. Yep, cool. Very good. What's next? Here we go. Right. Rubbish. Oh ho! What do we got here? Oh, it's a Morningstar. From Morningstar Corporation. Morningstar Sunkeeper. Doesn't look exactly brand new. Well, the box doesn't anyway. I'm not sure if it was supposed to be new, so that doesn't really matter. It's a Sunkeeper. When reliability and performance matter, but obviously Morningstar don't care too much about slamming your batteries with a sustained high voltage charge. There we go. Comprehensive manual by the looks of things. Okay, yeah, manual, you know. You're not interested in the manual, are you? You want to see the Sunkeeper itself. Oh, little baggie. And here we go. Here we go. There it is. The Sunkeeper 12. Now, I'll tell you one thing. These wires have got a lovely feel, eh? That's silicone. That's really, really nice. And you got this blue wire. Everything's potted, of course, so if we blow this puppy up, we are fucked. Can't fix it. So let's not blow it up. It's a 12 amp rated controller, which is actually 2 amps more than the Sun Saver, which I've got in the solar shed running the golf cart batteries. It's actually rated 2 amps more, which is interesting for a smaller, presumably less expensive controller. I got an excellent deal on this, otherwise I wouldn't have it here. But the thing that makes this a cheaper controller is it doesn't have any load control. Not that I ever use that, but it doesn't have a load control basically, and it doesn't have any kind of load. Well, there's no low voltage disconnect because it doesn't have a load control. So it's pretty simple really. Your yellow wire goes to your solar, you read to your battery, and your black wire is your common negative, because this is a proper common negative controller, as pretty much most Morningstar products are. So that's really a lot better, especially for what I like to do with things. Now this particular unit is designed to mount, I believe, directly on the solar panel itself. Like you mount this right on the solar panel frame somehow. I thought you were supposed to just screw it to the back of the junction box, but clearly, as you can see, the size of my fingers and the size of that nut, and this doesn't even undo anyway. That's not the case. That's not the case. But it does mount somehow on your solar panel, supposedly right behind the panel. A bit like a, I don't know, a bit like a, you know, micro inverter or something, but it's not a micro inverter. So that's that really. Oh, the blue wire, I suppose you're wondering what the blue wire is. Well, I presume you can cut that and it'll change the mode of this. It's either to choose between flooded and sealed batteries. They don't specifically say gel with any of these Morningstar products. It's like flooded and sealed batteries. Or it might possibly be to control the PWM speed, because the Morningstar normally runs at about 400 Hertz. But you can, there's a wire inside the Sun Saver which you can cut, and it'll then reduce its operating speed down to about 10 Hertz. And the reason why you might want to reduce it is if you're running telecommunications equipment and that PWM frequency finds its way into the audio or even the RF circuit somehow, I guess. But I'll have to read the manual. In fact, should we look now? That's actually getting a bit long, this video. I'd wanted this to be short, but I guess we'll find out. Lock nut. Oh yeah, no, you do use it. No, apparently you can screw it directly onto the junction box of the solar panel using that. There we go. That's how you're supposed to do it. It would have to be one mother of a junction box on a solar panel to have that screw right into the side of it. Jesus. But apparently that's what you do. And of course it's surface mount, blah blah blah. Okay. Well, it looks like I was wrong about the wire. Apparently, well, the grey wire is the grey wire. There's no grey wire. There's only this blue wire. That must be the wire. It's actually a temperature compensation section 2.1. There we go, 2.1. Okay, 2.1. Right past it, didn't I? There we go. Oh, here we go. Okay, that loop of wire is the temperature compensation selector. The Sunkeeper has 3 temperature combination options. The grey temperature compensation loop can be configured for the following temperature compensation options. Loop not cut, internal temperature sensor used for temperature compensation. Factory default. So you don't cut that and it'll just use its internal sensor. Loop cut left open, no temperature compensation. Insulate caps and loose ends. But you can also apparently cut the loop and connect it to an RTS, remote temperature sensor, but you must use a proper Morningstar one. So there we go. So I'll probably just be leaving the loop and letting it temperature compensate itself. So there we go, a bit of Morningstar product there, and a bit of cheapies there, bit of cheapies. So you know, this, oh look, it's the manual for the PWM5. Yep, that stopped me freaking out the other day when it was first flashing its LED, and I was going, wow. Oh, I've never had that issue. I've never had that issue with the PWM5 where it where you inadvertently tell the LED to stay off by misconnecting it. That doesn't seem to really be a problem with it. I think you'd have to be pretty unco to actually end up with that problem, eh? I don't think really it is an issue, and I can actually see now why Julian actually wanted to disable the LED, because that LED is flippin' bright, eh? It's flippin' bright. So, you know, if it was in your boat cabin or RV or something like that, you might want to turn off the LED. I suppose you could just put a bit of tape in front of it, but the PWM5 is working wonderfully. I've seen it PWMing now and all that kind of stuff, which I should make a wee video of. But wow, this is already getting long and rambly. I'm not supposed to be doing solar at the moment. I'm supposed to be preparing for the summer solstice, but I've got the new Beltane track that I'm posting up tomorrow on day 348 online for people to listen to. That's already been done, mastered, mixed, finalised. I'm pretty happy with that. And the new track we're going to be recording on the summer solstice has been done, and we've been rehearsing that. So everything there is under in check, really. So let's just go back to playing with solar. In fact, I did actually do something today before that Postbag video that was the reason which drove me to unpack those products, actually, is because it's finally time to do something with this battery here. This is a Crown 130 amp hour 12 volt deep cycle battery. I got it reasonably cheap. I'm not convinced about its performance, but I'm going to try and improve it by doing the whole hitting it with a 15 volt charge like I've been doing with those golf cart batteries over there, and very successfully. Oh, and while we're at it, the timer appears to be working very, very well, but I haven't checked to see how much liquid's in those batteries yet. Should we do that now? Should we do that now? Why not? There you go. There's plenty of liquid in that one, and it's bubbling away nicely now because it's after 5:30 and the power has returned to full volume. What do we got there? These are the shittier ones on the left hand side here, these pair of batteries. They gas a bit more because they're a bit older. And they're doing pretty well too. Looks like there's still plenty of liquid in there, so I think the time switch is doing the trick by cutting down my need to put so much water in there, which was the point of it. Running at high voltage has not appeared to do any harm to the batteries apart from needing more water. I mean, it could be slowly blowing material off the positive plate or something, but hasn't shown up in lack of performance. They've been going really, really well. They've been going like that for quite some time. But anyway, what I did today, yeah, this battery here, I want to do the same kind of thing too. So I have decided it's time to put more power into this than what I've got here. This is an old SolarX SR4, and it's just being fed by a 15 watt amorphous panel which comes down this orange cable from the roof. And that's been enough to maintain this battery, of course, so that it doesn't go all sulfatey. And at times I've ran this cheap little desulfator on it, which I'm not 100% convinced they help that much. A little trick though with that is I put this inductor here in series with the power wire so that the pulses from the desulfator don't disappear back up the wire, so the solar panel, they stay going into the battery, because this would present a high resistance to a high frequency pulse, a transient pulse, because it's essentially high frequency because it's such a sharp pulse. But anyway, so to make this happen I need to put more power into this battery, and I'm going to get that from the main 12 volt array, the big array, and so I need to get power over this side of the shed. So that's what I worked on earlier this afternoon, which is, it's one small thing. It's one of those small things that, I'll just put a power cable in, but the doing of it's always, it's awkward. You've got to sort it out, you've got to find the right bit of cable and everything, but I've done it, so I'll show you that. And that'll do for today. So this here is basically my combiner, where all the panels from the roof and the 12 volt system come in. They come in through these breakers here, and they're just basically combined by this loop circuit on the bottom here, and these wires here feed off to the various circuits where that power goes. This red wire here is the new one, and if you follow it up, it goes to this bit of cable here. This is just 6mm TPS. So there's the red wires there, and the black and green I've paralleled to the negative bus bar down here. Now, a sneaky thing that all these cables do with this TPS is that it's 6mm TPS, which means that what would be the phase and the neutral wires, the red and black ones, are 6mm, but they always go a bit lighter on the earth, so it's not a 6mm wire. It's actually, by my judgment, it's about a 4mm wire. But the sneaky thing is that they actually use thicker PVC plastic insulation on the earth, so therefore the wire with the insulation on occupies the same amount of space. I guess that helps it stay neat in the sheath there. So yeah, I've hooked those up at that end. This was an old bit of cable. I think it came from somewhere coastal. It might have been something that led from the top of a power pole down to a power box. It may have in fact come from the old range lights around at Hastings when Napier when we went there one day, and there was bits of pieces of stuff lying around, but I'm not sure about that. I may have picked it up down Foxton Beach, but I think it's been in some kind of, quite possibly been in a marine environment. It was a little bit corroded here and there, but I cut that off. So there we go, that just follows down here. I'm just going to about to cable tie these low volt or low current lamp wires to it, and it comes down here to basically nothing. There's the ends there. So you can see they're well weather beaten. This was the end that was up the pole. There was a butt nut, they called, hooked to the negative wire, which I've since cut off. So from here I can put a board in and put the Morningstar or whatever controller I'm going to use and run down to that battery, and maybe some more batteries down here too. So that'll be yet another battery circuit. So I'll have quite a few battery circuits in here now. But that's probably all I'm going to do today. I'm kind of taking it easy at the moment, so I mean that's enough for a mellow puff, as they say, you know. That's the difficult part, really, getting those wires in, because, you know, you wrestle this cable and it's bending around everywhere and it's threatening to snag other stuff and pull it off, and, you know, that kind of thing. So it's in now, so that's all good. Well, I thought I'd just give the Morningstar a quick trial run in the workshop here on this old car battery, which I use for powering my funny internet fix. This is the second one, of course. The other one's out there doing it, and this is the one that's being recharged. I normally use a different charge controller to do this. I'll make a video of that another time, but I've substituted the Morning Star here to do the trick, and there we go, it's doing its thing. You'll notice that the light's on with an occasional blink. That's what it does. The light's on like that when it's in the bulk charge mode. Apparently it does have a float charge mode, this Sunkeeper, which is interesting. And that's pretty much it. Oh, I have incorporated my diode trick. Yeah, because I thought, well, if I'm going to test it, I might as well test to see if this is the same as the Sun Saver and that I can do this, and of course I can. So, this is the configuration. Positive, of course, is connected to the positive of the battery, as one might expect, but the negative of the battery terminal here doesn't go straight to the black wire, it goes via this diode. So the anode of the diode is connected to the negative of the Morning Star, and the cathode of the diode returns to the battery. So it allows current to return to the battery, you know, so it comes out of here down the black wire through the diode and back to the battery. So that's essentially the voltage that is drawn by the unit running and also sampling the voltage of the battery. So this diode introduces a 0.6 volt drop, so it tricks the Morning Star into charging the battery 0.6 volts higher. If we wanted to go 1.2 volts higher, we could use 2 diodes and so on and so forth. We could actually even start using Zeners or whatever, but that would get out of hand really. There's not very much current flowing through this wire at the moment, so that 10 amp diode there is a complete overkill. And the charge from the solar, of course, the positive's connected to the solar input, but the negative, of course, goes straight to the battery, and that's the key. So the path for the solar panel goes through the yellow wire and through the red wire to the battery, and it returns via this green wire directly to the panel. But the Morning Star's negative is jacked up by 0.6 volts on the diode there, thus we can get this to charge to a high voltage. It's quite an easy trick. You could do it with a positive earth charge controller. You would just have to put the diode around the other way in the positive line. It's easy to raise the voltage of these controllers. It's a little bit trickier to get them to charge at a lower voltage should you want to. But for my application, I want them to run a bit higher. Oh, and it turns out that this is actually set for sealed batteries permanently, so therefore I do have to raise it even if I wanted to charge a flooded battery at normal levels. So, but it's all doable. It's all doable. And the temperature compensation still works even when you've got this sort of Mickey Mouse arrangement to try and trick it. The temperature compensation will still work, so it's pretty cool. So just thought I'd show that. This video is already long, it might as well just be mega long, on day 347 off the grid.